Hello, hello. Good afternoon. Thanks so much for your valuable time. Hope you had a great lunch, a great morning. This first starting. And today, the idea is to advocate a bit about the data engineer, specifically with Python. I won't talk about the tooling, but more about concepts. And of course, Python, how we can make the things more Pythonic. First of all, some disclaimers here, just to let you know that I'm not endorsed or affiliated to any conference on foundation. This is a very condensed overview about what I wanted to say. You have just 40 minutes, so I had it too short. Sometimes I will be a bit rushed, but feel free to hands up your hands, ask anytime, even you have a QA in the end. If you don't understand or have anything, just hands up. Unfortunately, I planned a live encoding, but unfortunately, I cannot make it. The time is too tight. It's not about operational data or platform itself. It's just about the components, the opinions on my own. And of course, feel free to reach me out after the talk anytime here or in my social contacts. Introducing myself a bit, so I'm Brazilian. I'm living here in Berlin for almost 8 years. I write Python code for more than 20 years. I started Python 2.2 when I read this book first, when they were released. Since 2011, I've been organizing meetups, conference, mostly in Brazil. I had a pleasure to organize the Python Brazil in 2015. Also, I'm inviting you, so if you want to travel to Brazil in October, you have our PyCon or Python Brazil edition in Rio de Janeiro. And it's October 16 to 21. You're more than welcome to go. In the last 10 years, I've been focusing on data engineer and data ops. I've been working for several markets, real estate, food tech. I spent several years in Microsoft and GitHub. And recently I joined to Delivery Hero, so I could see different point of views, how to manage data in different situations, in different scales. And in my free time, I really love cats. I try to hunt the spicy foods in Berlin. I learned to paragliding, and now I'm learning to paramotor. So it's how I try to spend my free time. Today I wanted to discuss a bit more philosophic, why to discuss data engineer fundamentals in general, and then you're going to expose anatomy of a data product. It's pretty much generic, but any data product has a specific anatomy. You're going to talk about the data formats. That's very important when you need to link those components, or flow management, how you manage several steps of your data, how you distribute your code to run at scale, and most important, and sometimes people neglect it, is about data testing and validation. Why you needed to discuss this kind of topic? First, being pragmatic is the key here, because you want to solve problems. And solve problems doesn't depend on silver bullets. Why? Because when you go to blog posts, to Medium, you tend to see how fascinating those companies solve their problems at scale. They link several components, and they make a lot of magic, and they release a product as an open source, and they started to make a lot of things on top of that. But people don't really think sometimes that being pragmatic is what problem I needed to solve, what the scale of my data. So practical thinking to solve those problems in a real world, that's what I'm trying to show here. And I'm still advocating that, of course, you have several tools, several companies doing a really nice job, but what you call it, the traditional methods is still a thing, but that you can rely on. It's adequate for a small or large company. I see it, for example, when I work for big techs in general. I'm like working like in a petabyte scale, and then traditional methods still can handle in a very affordable way ways to manage your data. And the first thing you needed to answer is, why do I need like a data engineer? Basically because you have a lot of mass information flying around the world, and then you needed to structure it, you needed to organize it, and then you needed to make accessible for the people. How you make it? It needed to be reliable, you needed to be efficient from the point of view like affordable costs, because you cannot spend like millions of dollars to spin up several clusters to process data, so you have several techniques. You have several ways to make it like in a low cost, but also you needed to think how to scale up in the future. Don't believe like in silver bullets. Try to think and try to make this puzzle by yourself. Because other things is that your data mostly doesn't fit in your own machine. Even you have like a super machine, so your data might fit there, but you have a problem to process there. So you need several aspects of your data you need to fit into, to have like to access our data, to process our data in an affordable way. And the most important is like, data is part of your business all the time. If they are not part of your business, most probably data is your business. I see a lot of sponsors here that the data is the business. So you have like that cliche for 10 years ago that the data is the new oil, the new energy, whatever. So imagine that, like treat your data like you treat yourself, like you may. And you are in a Python conference, like, of course I needed to say, like, why do we need to choose Python here? First of all, like, so the vast amount of resources that you have like several open sources, they are well maintained, you have like many tutorials, you have like a very diverse community that like spread the knowledge, meetups, is a growing ecosystem. Every month you have a new tool, a new technique, someone trying to make something different. Most of like the tooling that's not the Python is well integrated with the Python ecosystem as like a generic tool. For example, who works with the data engineer probably has at least one component from the Apache Foundation in your pipelines, in your architecture, and most of these components are based on Java, JVM, or something. But most important that the Python itself is on top of most of those tools. And also that our house systems from the cloud providers also provide like native Python integration if you needed to generate like user-defined functions, or if you wanted to run small jobs for any most biggest providers. Let's talk about like the anatomy of a data product. It's pretty generic. Any data product has a similar approach. First of all, you have sources. For you have like a data product, you need to have a data. Where the data flowing on, there's several ways for that. It can be like an API, a database. It can be like images and structured data, streaming data. You have your app, you have your website, so users are interacting with that. They are collecting events, and then we have the sources. This is the very first part. But for that, we need like a common format, something that can be translated and be efficient, that you can consume your data, structure, validate, and then you need to transform it. Any transformation step relies on a data storage. It can be ephemeral, can be like a distributed file system, can be in memory, independent, but they need to be stored somewhere. And then this transformation happens because you get your data, you make some cleanup, you make some change, whatever you want to do, but in the end, they needed to be stored. And in the second, you need, for the third, sorry, so you need to serve it somehow. Probably you put in a database that the people you query that, or you expose over the API, or you send it back to another system. Independent of that, so you need to have like this transportation layer, this serving layer. And to manage everything, so you need to rely on orchestration. So when you link all the points, we need all the tasks, every step that you need to make your data. And of course, you need to observe it. You need to monitor it to make sure that everything is running smoothly, so you don't have errors. If you have errors, you need to be alerted. And then this is the anatomy of basically any data product in the world, of course, with your fancy names, with fancy products, fancy tools, but like our body, everything is an arm, everything is a leg. So for the data product, you have like those steps. So I'm proposing here in the next 10, 15 minutes is like to imagine to build a data product in our mind. So as I've mentioned it before, the first thing is to define a data format. So how you transfer the data between all those steps. There's several choices. People use, for example, JSON, Parquet, CSVs, or they choose. For this moment, I'm suggesting here a Pythonic way to do it, PyArrow. PyArrow is a project from Apache that's like writing in C and parts in C++, but they have like a wrapper over the Python. So it's a high efficient like analytics platform in memory. This is very important, that avoids serializations between the data formats. It's very interoperable. They have a lot of interoperability because we don't need to serialize the data between them. It means that, like, for example, if in your pipeline you have consuming like an API or something, so you can push, send it to or create like your PyArrow structure, and then they will be available in memory for you, and then you can work as much as you can. But like, as you can see, like PyArrow can be like a data exchange format, is a in-memory format, they are network format, because of course you navigate between the network. Is a storage format because you can choose how you want it to write to make it to the storage. Is an I/O format because you have like these transfers between the CPU, GPUs, and memory. Is a carry engine, so if you wanted to perform some analytics, they provide APIs for you. Also, they are partition manager, so if you have a massive amount of data, you can partition your data, you can manage it. They works like pretty smoothly with like data frames from pandas, from Polar. So if you have a legacy code, or if you have another steps in your pipeline that use those tools, you can like easily to use PyArrow. So in a very Pythonic way. And also they have like vector computing. So if you are doing like things with GPU and all this nice stuff that's come up, so PyArrow is very affordable for it. It's very easy to use, just the PPI install PyArrow, so you have it available in your virtual environment, just push. And here is a code sample for it. Basically, you can push any data. Here I create like a list of dictionaries with like a structure, and then you can define a schema. This schema can be very detailed, so they support like a complex type, lists, dictionary, nested formats, and in the end you can use like the table or from PyList to create your structure. So it can be from lists, from dictionary, from external files, from data frames. So you have like a vast amount of options for work. And also, as I mentioned, so you can also partition your data. So in our case here, what you are suggesting is basically you get all this data from the talks, and then you can partition for data, for example, and you can see that, for example, they will generate for Parquet files for you. So it's the way. So when we needed to read this data set, so they will come to the data for the PyArrow, the arrow format again. It's pretty easy to make, and then makes you more reliable, because when you are defining, when you are talking with your stakeholders, you can define the schema of your data format, like basic validations, and then you make sure that the data that's flowing to your pipeline, into your system, is like at least pre-validated at some point. And the second step is like to orchestration and observability. So in fact, this is like the tool that most of the people use. There's other choices in the market, but then Airflow. Airflow allows you to use like Python codes to create like graphs or tasks that link it to each other, so you can schedule those tasks. And they also provide like a set of tools, like including like a graphic UI that you can see. That you can see your what you call the DAG. You explain the next slide. They have like dozens, like hundreds of integrations with several services, several libraries, so you can customize by yourself if you want for any type of workflow. Imagine, again, you need to go to any API, push that data, do a snapshot to our database, do the snapshot, make some cleanup, make some analysis, and then output this data to other places. So Airflow, you orchestrate for you. But the most important is that they have like internal mechanisms that allows you to observe it. So they collect metrics that you can use like your tooling for metrics like Prometheus, Datadog, Sentry, whatever you want to use. You can link on top, and then you can have like graphics, understand how healthy your ecosystem, your platform are working. And then some of the user cases like ELT or ETL, depends how you call it. So automate generate reports, if you needed to generate reports on a daily basis, for example, backup tasks, snapshotting tasks, and is widely used for training models for machine learning. And some of the concepts that you need to keep in mind. When you say in Airflow that you have in a DAG, basically you have in a Python code. Python code, how you structure, so you define the configuration for that context, how many operators do you have. Operators is a unit, a Yerk unit, that can do everything you want. Connect it to a service, execute a query in a database, write to somewhere to make some analysis, to execute a command. Operator can be extended, can be customized as much as you can, and then you have the tasks. Basic tasks are the graph itself, so how you link one operator in each other in a context of an DAG. And then you have like a sequence. DAG means like directly acyclic DAG. Basically, it's a graph with just one direction, so you can configure it. But one of the most powerful features in Airflow is the templating. So if you are using it to use Jinja templates for other projects, so you can use the same concept like in Airflow. So you can create your macros. You can like standardize like commands, queries, files. Everything is on a template. So it's pretty much useful. And Airflow works like with like 5 main components. You have like you call the metadata database, is a relational database that controls all the aspects of the Airflow. And then in the core, you have the executors and the schedulers. Scheduler basically is the cron job of the Airflow. Basically, you can configure how your DAG you run. So you configure the rules, if each hour, if 30 minutes, if daily, if every Monday. So it's just up to you. And the executor is the queue who manage how you create the workers. The workers is the code of the operator that you run in a specifically unit work. Depends how you deploy it. For example, if you deploy in a Kubernetes, so they will spin up a pod for you specifically for that piece of code. They will run that code in the pod. They will get the result. This is a worker. They have an accelerated work, or they can execute in the same machine. And as I mentioned, you have the code that makes everything happen. That's we call it the DAG. And in the end, so when you deploy or use a service, or Airflow as a service, you have a web server and a UI that you can interact with. It's a bit small, but I will try to explain a bit. In this part, so when you create like the DAG context, we import, so you create the context for a DAG. So you can define the scheduler, you can define when this DAG starts, the name of the DAG, some DAGs. And for the second, you have the operators. You instantiate the operators. As I mentioned to you, you have 100 of choices. So you can connect, for example, to Azure, Amazon, Google, third-party tools. You can create your own operator, custom operator. Basically, you chain it. The third one is if you wanted to create a template. If you want to, for example, to execute a complex command line for a specifically serving a remote job on a remote server, for example, you can create a template for that, use the parameters, and they will render it for you in Airflow. And the magic happens on the last line here, where you chain, where you put your tasks to work together. Like you say, these tasks depend of these tasks, that's depend of these tasks. If one task failed, don't run the next one, or run the next one. And it turns into a graphic UI for you. First of all, so when you deploy your DAG to Airflow, pretty much easy, probably you're gonna see something like that. For example, our PyCon DAG that you generated. If you get into the DAG, probably you're gonna see a kind of graph for that. So, and each step is one worker. Each worker has your results, has your own logs, so it's completely monitored by the Airflow. Now that you have like a data format, now you have like your orchestration, sometimes you need to think how to scale up this project along the time, and the choice is Spark. But Spark is writing in Java in a Python conference, but like the most important here is talking about PySpark. That's the wrapper between, is the wrapper on top of the Spark. And why? Because it's a real-time and large-scale processing. I will explain how it works behind the scene, because even it's a Java or a Scala tooling, what is executed in the workers is a Python code, and it's because you are here. Because there's like this magic with the Py4j here, and supports all the workloads from Spark, including the machine learning. So if you are doing machine learning with Spark, so you can use PySpark. And the concept here is very simple. You have like the Spark context, that's the code that you are writing. So you are getting the data from somewhere, you are doing transformations, you are doing several tasks on top of that. What behind the scenes the PySpark does? They serialize your code, your Python code. They, through the Py4j, they distribute this serialized Java objects to the workers. You can have like any worker you want, so depends the capability of your cluster. And the worker serializes it to the Python code again, execute everything they need, they shuffle in the data, they coordinate our data, they get the result, serialize it to Java again, and serialize it to Python again as a result. This is the magic behind the PySpark. But it's pretty much easy. Like, take this as an example. Spark works with the same concept data frame as pandas, like a very rough way. So here you are creating like three lines in this data frame. And let's say, for example, that I wanted to create like a function that announces the talks for all the data that I have inside my data frame. What you do, you take like this method, you serialize like in a Java object, you spread it to the workers, you get the data that you create, like imagine that you have like a million of rows, you divide it between the works, you apply the function to this, the function to all the function to all workers in Python, get the results, and then you show up for us here. Basically, it's a map operation. The magic behind it is like Python, Java, Python, Python, Java, Python. But you don't need, like, if you wanted to use like a more affordable API, they do the same, but for example, you can do like a filtering, for example, like in a very Pythonic way. So you can use like the native objects, or you can use a SQL. You just needed to register a temporary data set. And in the context of Spark, this will be like a view or table, something like that in memory, that are available in the Spark cluster, and then you can execute in a SQL, very complex SQL queries if you wanted to do. And then, for example, you're gonna see, I put like, but it's not good, but like it's a similar. And here is like creating, it's creating a session, a Spark session, and read the same Parquet files that you wrote like in a PyArrow a few slides ago, and then you can see that you have like a well-defined scheme, or you can show up. For the list, test your data as you test your code. So sometimes you neglected it, but like it's very important to test your data, avoid reworking. So especially if you are in a small team. And here you have like one framework called the Great Expectations. That's a very Pythonic framework that's for the data quality. You have several ones. I will explain about the PyData after, but like one of the concepts of the Great Expectations is the collaboration between tech and non-tech people. Like when you define like your data, what you expect of your data, of course you have some expectations about that. So should have duplicates or not, or missing values, a range of values, negative numbers, whatever you want. And then how it works, they work based on the data frames from the pandas or the Spark. I put the two options here, but basically you can read your data source wherever you want for any format. In our case, we are using, you are using our Parquet files generated, and here I say that I don't want that this column author cannot be null. And then they give you all the statistics. Based on that, you can consume this output and define your rules. For example, let's imagine in our flow, you have a step for data quality. So you check our data, and in case you have some problem in our data, you can emit some monitoring, some alert directly from the Airflow linked with the Great Expectations. All the cycle ends. And by the end, so you have the PyData, that also is a data validating tool, but different from the Great Expectations. They are more focused on your business. It's a data validation because you know your data, you know your business, and they have like some concepts. The base model, so when you needed to create a validation on PyData, your data class, so you have like a Python data class, you needed to extend for a base model. That's the subclass, and they have like error handling by default. When you instantiate a new class, let's say speaker, that you show in the next one, if you use any wrong value, they automatically throw an exception for you, and they make the data validation for you. But the nice thing is that they use like the Python types annotation for that, so you don't need to do any other magic. Annotate your data. Like this, we have like a class called the speaker, so for properties, and then if you create like a wrong value, for example, the room here, the literals, I just accepted 3 values, I put one wrong here, probably you're gonna have like exception throw for you. And then the question is, Great Expectations or PyData? Both are validation tools, and you decide for use. But keep in mind, great expectations is about what you expect from your data, like the basically validations, and it's well defined. It should contain null or not, range, negative numbers, and Pydantic is more about business validation, let's say, because you know your data, your business. Work both together to understand. But like the last one is just not about data quality, it's like to saving time and reduce errors, because you can understand your data from the start, and then you can perform, for example, regression tests, performance tests for it. And by the end is like our data anatomy, more or less, how you can link those components. PyArrow here that you can navigate through the sources. So you have a data format, a common format that is affordable for most of the scenarios. The transformation, Spark, PySpark here that make the transformations, they manage the data storage, and between you might have like several validations for that. For serving, so PyArrow also is a good choice, because imagine you are working like in a huge project, and then most of your people from the analytics are trying to make some analysis on your top, so you can just provide a PyArrow pointer for them, and they can manage, because they can use pandas if they want, they can continue using Spark or any other tooling. And to manage everything, Apache Airflow for it. And a big thank you for attending your valuable time here. So if you wanted to contact me, my LinkedIn, my GitHub is BSAO, just like I did, drop me a message. Or if you wanted to talk directly, my Telegram is BSAO0. Thank you so much.
Thank you so much for your talk. It was really insightful. So I have a couple of questions. So the first question is, can you recommend how to organize DAGs in Airflow if there are 50 plus of them? Are there folders? Does it make sense to enforce a naming convention or tags?
Again?
Sorry, so can you recommend how to organize DAGs in Airflow if there are 50 plus of?
Okay. Airflow in general, they have like a standard for that. So any of your DAGs by default are inside the DAGs folder. So you have your project, you must have a DAGs folder by default. If you wanted to customize, you have some configurations that you can do, but the DAGs folder is the default. If you wanted to create custom operators, you have like the plugins folder. So by default, you can change it as well, but in general, when you need to organize an Airflow project, you have mainly two folders, the DAG one and the plugin one. And then you put your code inside there. In general, you pack it in a Docker container with this structure, and when you install your Airflow, you have like the Airflow command line that you can perform several tasks on top.
Thank you. So I have a next question. So it's from Stefan. So the question is, Python to Java, Java to Python serialization marathon looks tedious. How much of a pain is that in practice? Example, with respect to debugging. Okay, sorry.
So how much it's painful? How much it's painful? No, it's not painful because it's a problem that is already solved by the community. So people working hard behind those open source projects, especially the PySpark or the Spark, they already handle all those problems for you. Specifically in the newest versions of Spark, you don't even need more to configure several variables in your environment. So if you wanted to use PySpark, PPI install PySpark, just needed to have like Java installed in your machine, and all the magic behind you happen transparently for you. Write in your Python code, when you execute, even a debug or in a command line, the magic to transform, it will happen transparently for you, no painful anymore.
Thank you. So the next question is, how do you test your airflow in DAGs?
Distribute?
Yeah, the test your airflow in DAGs. Like the question here.
Airflow as an operator, as I mentioned, so when you create an operator, basically you extend on a class called the base operator. Like in Pydantic, you have like the basic model. Similar approach for Airflow, so you have like the base operator. The base operator has some methods that you need to implement. How to test it? Unit tests, because you can mock parts of your code. It's pretty much easy. Introduce unit tests for Airflow is very easy because an operator is a class. So you can test at the class. You can predict like what's the input, what's the output. You can mock parts of them, for example, connections or other outputs. But overall, testing Airflow is a similar approach of TDD unit tests.
Thank you. So I have one more question. So how do you handle validation error in production? How do you handle validation errors in productions?
In production, so you handle the same way in your pipeline. So most of the people, or it's a good practice. So when you process your pipeline, in the end of your pipeline, probably you have some task for the test, for the validation. And in that moment is how you test in production. Because in production, your pipeline is running, so you are input or output your data to somewhere, and then you test there. For example, for Great Expectations, they have your output with like information for you that you can store it in a database, for example, or you can send it to a observability platform. For the Pydantic, most probably you have like exceptions being handled in your code, and based on that you can manage it. But like it works for production or development or staging, whatever how you use.
Thank you. So I have like another question.
Sure.
I mean, so the next question is here. What is the difference between streaming and eventing in incoming data? Streaming and eventing in incoming data.
Streaming and event, they are pretty much similar, but the most different is that like you are consuming, streaming, you are consuming for some topic, from some message queue, it's involuntary, you're just pushing. Event intends that like your external systems informs you, like for example, one very common use case is CDC, for example, new techniques, you want it to be informed from your database that some row changed. Instead, do like snapshots from the whole database every day. Basically, the database informs you. They send a message to your system for a Kafka or any other management system to say like this row changed, they were updated, deleted, inserted, and then in your pipeline you can just manage in a row level. But they are pretty much similar.
Thank you, Robson Junior, for your talk. It was really an insightful talk. I'm sure we have a lot of questions. So after the talk, you can connect to Mr. Robson for the rest of the question. Thank you so much, everyone, for today. Enjoy the rest of the talk. Have a nice time ahead. Thank you so much.
Thank you so much.